Welcome MA 103 students. This video AI corresponds to the lesson entitled Modeling with Linear DDS. In this video, we will focus on the first lesson objective listed here, model situations and solve problems involving linear DDS models. There are a series of 4 video AIs based on the USMA mathematical modeling process for the lesson Intro to DDS that can also assist you in understanding this first lesson objective. Here we will use the USMA mathematical modeling process in order to solve a problem. This first video will focus on the first step, transform. This is a problem that we'll use for this video AI that comes right out of modeling in a real and complex world. Suppose that we send one rocket to the moon each year with 75 colonists for 20 years to set up a permanent colony, and the birth rate on the moon is 5%. That is, each year, the number of babies born is 5% of the current population. Additionally, assume that the death rate is 1% per year. What would the population of the colony be after 20 years? What assumptions did you make? Use a discrete dynamical system to model this situation and answer the questions. First, when we take this real-world problem and transform it into a mathematical model that we could then solve, we need to identify what is given in the problem. Here you can see we have a birth rate, we have a death rate. We also know that the rocket actually goes to the moon each year, and we send 75 colonists each year for 20 total years. Next, let's determine what we have to find. We want to find, based on that first question, the population of the colony after 20 years. Knowing what we need to find helps us then define the variable of interest. Defining our variables of interest is really the first of the essential elements of the transform step. Here, let's define P sub n to equal the number of colonists on the moon after n years. If we were able to find P sub 20, we would be able to answer our question. The next step before we actually develop a model is to identify some assumptions that will guide us in developing the model. The first assumption that we should make is that there is not a permanent colony on the moon right now. No one is living on the moon. And we do this so that we can determine our initial condition, our starting point for the population in this permanent colony on the moon. Let's think about some other assumptions that we need to make to progress with our model. I'm going to make the assumption that there are no advances in medical technology that would actually change the birth or the death rates on the moon. Our problem specifies the birth rate at 5% and the death rate at 1%. And I want these to be consistent throughout these 20 years of this permanent colony on the moon. I think there's another assumption that we should make, and that's that no other nations are going to develop technology, have the same goal, join us in our endeavors and add more colonists, or create their own permanent colony, which would influence our objectives and our progress on the moon. Now that we've identified these assumptions, it's important to think back. Think about why these were necessary and why they're reasonable for our model to make sure that we're going in the right direction in creating this model. We said that that first assumption was really tied directly to the creation of our initial condition. So let's develop this discrete dynamical system by starting with the initial condition. Based on our assumption, we're saying there's no one at the moon to start this colony, and therefore our P sub 0, our P naught value, should equal 0. The next aspect of the transform step is truly to develop that recursive relationship that exists. So we need to find an equation for P sub n, where P sub n equals P sub n minus 1 plus whatever is changing. So remember how we formulate recursive relationships. It's the concept of where I am right now, the present, equals where I was the time before, the past, plus things that change. So since we have the general structure of our recursion equation, let's identify the things that are actually changing. What's changing year by year on the moon? Well, we have a birth rate, we have a death rate, and we also have the addition of 75 colonists every year. So we have three aspects of this scenario that are actually changing, and we need to incorporate all three into our model. You can see the three aspects that we've incorporated into our model. So P sub n equals P sub n minus 1 plus, and then the three aspects that have changed. The birth rate, 0.05% of P sub n minus 1, minus the death rate, 0.01 times P sub n minus 1, plus the 75 additional colonists that are added to this permanent colony every year. If we combine like terms, we can see that our recursive relationship is P sub n equals 1.04 P sub n minus 1 plus 75. Based on that, now we have a discrete dynamical system with our initial condition and our recursion relationship, our recursion equation. This is our mathematical model that in the next video we'll use to solve.